Greetings once again from Rescue Shuttle Control. It's very exciting news to learn that you have succeeded in activating your navigation systems and have them up and running. That brings us much closer to our eventual goal of activating all of your shuttle systems and lifting off the planet. So today we're going to continue to develop some new techniques and some new capabilities that will bring us closer to that goal. Today, we're going to be focusing on a new form of output, this time utilizing a graphical display. We've done some things similar to that in the past. We've dealt with lighting LEDs, both monochrome LEDs and RGB multicolor LEDs. And we've also done quite a bit of work with things like multi-segment displays and keypads. And so today we're going to learn how to display information on an OLED display, an OLED display. That stands for Organic Light Emitting Diode. And this OLED display, which you can see an example of here in front of our camera right now, is a display that allows us to show 128 by 64 pixels. It's not very large by comparison, say, with a widescreen TV, but it will give us the opportunity to display information in a more concentrated form than we've been able to do so far using the devices that we've learned to date. Our display, being 128 by 64 pixels, means that it has that many separate LEDs that can be turned on and off in order to create a graphical image or a text image. That's 8,192 separate LEDs. And you can sort of see from that alone that it wouldn't be possible to control those LEDs one at a time in the way that we, say, controlled our LEDs in our earlier sessions. It would be completely impractical. We don't have enough output and input lines into the Hero to control the hundreds or thousands of different LEDs that we might need to use. So we need a different approach. And the approach that we're going to be learning about in today's session is a type of communications protocol that can be used between communicating devices. In this case, a protocol that can be used to communicate between our Hero and the OLED display. Now, our OLED display is going to be controlled by software through another library, an external library. And so you'll be needing to load that library if it's not already accessible to your Hero. And that'll be using the same method that we've used before to include a library, where we basically go to the tools and manage libraries and import the library. Specifically, the library we'll be looking for is the U8G library, U8G lib. And we'll see more about that when we start talking about the code shortly. For now, however, I wanted to talk a little bit about this communication protocol. It's called the I2C Serial Communication Protocol. I2C has a wonderful capability, and that is that it can send the data necessary to control this 128 by 64 display over a single wire. And that might seem impossible, but the way that it's done is that single wire carries a message. It carries a message in the form of data packets that are communicated between the two devices using a handshaking protocol. So the single wire simply carries a series of pulses that both the sender and the receiver understand and can interpret in an agreed upon manner. And that allows, in this example, the OLED display to be turned on and turned off and to control specific pixels because of the messages that are sent over the I2C protocol. Now, let's look quickly at our OLED display so that we know a little bit about the connections to it. I said that the I2C protocol sends the data over only a single wire, and that's true, but we need more than one wire in order to use it because, for example, in order for the two devices that are communicating through I2C, they need to be synchronized so that they have a common clock, a common heartbeat for interpreting the pulses that come down the data line. And so in addition to the data wire, there also needs to be a clock wire or a clock line that synchronizes those two devices. And we also need a couple more wires because our OLED display, like most of our devices, requires a source of power. And so we need wires that will send power to the OLED display as well. So that's the reason why, if you can see, it's a bit small here on our screen, but there are 4 pins that connect to our OLED display corresponding to 4 wires that we'll need to connect. The farthest left one is labeled GND for ground, and so that's clearly the 0 volt or negative voltage of our supply wires. Right next to GND is VCC, and you might remember from our earlier sessions that VCC is a traditional designation for the positive supply voltage, our plus 5 volts that we'll get from the hero. And then the next 2 pins to the right of VCC are SCL and SDA. And those should be easy to remember. The S in both cases stands for serial. SCL is serial clock. So that's the one that synchronizes the devices. And then the important one is the last one, and that's SDA, serial data. So SDA and SCL will be the 2 important ones to pay attention to in a little while when we look at our wiring to the hero. So what we're going to be focusing on today is really just the most basic possible use of the OLED display. We're going to use it to display some very simple text information and just be satisfied with getting that working so that we can, in subsequent sessions, work our way up to more elaborate applications that we'll be needing to control our shuttle as it takes off and flies. Now, let's go ahead and have a look at the wiring necessary. Since we're just testing the OLED display and no other functions in today's simple exercise, the hookup is actually very simple. As we mentioned before, there are really only 4 wires that we have to connect, and those we've pretty much already discussed what they are. You'll notice that we have our 5 volt and ground connected to the red and orange leads of our ribbon cable here, and those are connected to the 5 volt to VCC and the ground to ground. So that provides the power necessary to operate the OLED pixel display. And so then the other 2 important wires are the wires for clock and data. And what we need to know in this case is that the hero has 2 specific pins that are designated for use using the I2C protocol. Those are pins A4 and A5 down here in the lower left-hand corner of the hero board. So A4 and A5 are the data and clock lines respectively. So that basically tells us then that the blue wire here, which is connected to A4, which is the data, is connected to SDA, and the green wire is connected to SCL, the clock pin on the OLED display. So that's pretty simple, and there's not much more to talk about as far as the hardware is concerned. So let's turn our attention now to the code that we'll use to actually activate and control our graphical display. The graphical display is actually capable of drawing not just letters and numbers, but also shapes of various kinds that we can represent by pixels that are turned on and off. Although we'll be doing just the tip of the iceberg here and just doing a few simple commands to get our feet wet in today's session. So let's have a look at our code. You'll notice that, as I mentioned earlier today, the U8glib needs to be included. And so I've already done that. I've already made that available to our system right now, and included the U8glib.h file so that we can go ahead and use the corresponding functions to control our panel. There's a wide variety of different OLED display panels, different sizes, different types, and so you have to make sure that you are utilizing the correct one corresponding to your hardware. In our case, it's this U8G SH1106 128 by 64. So this is a type of graphical object that our library knows about. And so we're going to define an object of this type and give it a name we'll remember. So the name of our object of this type I've chosen to be my U8G panel. You can name it whatever you want, anything that makes sense as you're writing your code. I just chose my U8G panel as a way of remembering what this is and what it does. So we've declared this object, and now what we can do is use that with a variety of built-in functions that we'll be learning about. We'll only see a few of those functions today, although if you want to do some exploring on your own, you can certainly look into the U8G documentation and learn about the various graphics commands that are possible to use to control and manipulate the information that's displayed on your OLED screen. We are going to focus on three routines here in addition to our setup and loop routines, which we usually have. We've got a custom routine. Our custom function right here is called draw. And so that's a pretty suggestive name. Draw draws things on the OLED screen. This function, draw, doesn't return any values. It just does what it does. And we'll be calling this repeatedly in the other routines in our loop routine later on. This function we write, we supply it to do whatever it is we want to do in our application. So in today's application, our wishes are very simple. We're simply going to write one item of text on the screen in a particular location. And so that means that our draw function is quite simple here. You'll see that it basically has two important lines. The first line here uses the set font function in my U8G panel, and set font sets it to a particular Unicode font that looks good on our OLED display. And then we follow that with a drawString command. DrawString takes a couple of different, actually takes three different inputs: an X position, a Y position, and the actual string data that is to be printed out on the panel. We'll talk about this a little bit more, but the reason why we're setting this to 0 and 22, 0 means we're going to start at the far left position in X, and 22 means that we're going to start at 22 down from the upper left-hand corner of the display. You might be expecting the origin of the display to be in the lower left-hand corner, but the convention used for graphical devices like this is that the start is the same place that you start when you're reading a page in a book, and that is in the upper left-hand corner, and then work your way across and down. So this will start writing at a point on the left margin and then 22 pixels down from the top. And so that's what's happening in our draw function. All right, so with that simple task defined, let's go ahead and see what's happening in our setup and loop routines. Setup is really very simple. There's a few commands here that are actually commented out with double slashes. We commented out this one, which is called panel set rotation 180. If we mount our panel upside down, we might want to be able to flip the text upside down, and set rotation 180 allows us to flip the text upside down 180 degrees. If we've hooked up things correctly here today, we shouldn't need that. So we've left that commented out. The only non-commented line in our setup in today's session is this function that says set color index 1. So we have a monochrome display that can display different gray levels. And so we're going to set this to an intermediate gray level of 1, which means that when a pixel is turned on, its default brightness will be this value of 1. And so that we just need to do once at the beginning, and that's the reason why it's in our setup routine. All right, so next let's move our attention to the loop routine. The loop function in this case is a special loop function. It's what's referred to as a picture loop. When we're using a display like this, it's necessary to repeatedly call our draw function so that low-level functions within the U8glib and the OLED display can successively update the display until the picture is complete. And so you can see that what happens in our picture loop is that we have a do-while loop. This do-while loop will execute repeatedly until my U8gPanel.next page returns a 0, which means it's done. And so we will call draw repeatedly over and over again until this do loop finishes. And this is a little bit not clearly important in our very simple case today, because all we're really wanting to do is display a single block of text. Things will be a little more complicated and a little bit more interesting later on when we want to do more complicated things with our OLED display. Say, for example, we wanted to display a moving animation of some graphics that move across the screen. And in that case, we'll have to pay a little bit more attention to what's happening in the picture loop. And when we call first page, which starts the picture loop, and then when we stop, when next page returns a 0. So as I said, this won't be extremely important for us to get into detail on with today's very simple example, but you should keep it in mind as we look forward to some of our future exercises that'll be a little bit more complicated. All right, so with that, I think we're ready to go ahead and try uploading our code and seeing if it has the desired effect, which should be to display the phrase "Hello World" starting on the left-hand side of our display and down a little bit. So let's go ahead, let's check our code, verify that it is compiling correctly. It doesn't have any syntax errors in it. So that looks okay. Looks like the code compiled all right. So let's go ahead and try uploading it and watch the OLED display and see what comes up on it. So we're uploading. And in just a second, we should have something running. And there we go. There's our Hello World. So the text that we wanted is displayed, and it looks like it's displayed in the correct location. We can play around with this a little bit. So for example, if I wanted to move the text over to the right a little bit, I might say change this 0, the X position. Let's try changing it to 15 and see if we can get the text to move over to the side a little bit. So let's go ahead, save that, and upload it and see what happens. And sure enough, we've got the text to move over to a new position. You might want to experiment with some modifications of your own just to sort of see what the display is capable of and what some of its limitations are, particularly if you want to explore some of the other functions that you might find in the documentation. I'm going to try a little modification myself here just to see what happens. I might be able to, let's say, call drawstring more than one time. So let's see what happens if I do that. I'm going to call drawstring actually 3 times. So drawstring once starting 10 pixels down to, say, 1 line, and then 30 pixels down for a second line and 50 pixels down for a third line. So let's give that a shot and see what we can do. Uploading. And there we go. So we've succeeded in displaying our tagline, build everything and invent safe. And so with that, I will call a close to today's session. Very simple and straightforward session, but one that hopefully will get you thinking and prepare you for the next steps to get our shuttle up and flying. So until next time, remember, build everything and invent safe.